Hi, if you're like me, you were very confused with radians and radian measure, and I tried examining the pattern. So I used the textbook from OpenStax here, and I'm going to draw a little circle here. Kind of looks like a face, not a very good circle, but it will have to do. All right, I'm not using a ruler, if you can tell. So there's a couple different relationships here. So I hope you have an understanding of what a radian really is, right? And so 1 radian is approximately 57.3 degrees. Now, how did we arrive at that? Well, if you think of it as in terms of arc length, that's really what these radians are. So we're looking at arc lengths here. So you have your little angle, right? Let's say this is a 45-degree angle here. Okay, what's this going to be called? Is this the terminal side or the initial side? This is the terminal side of the angle. Here is its initial side. So what are we really looking at here? Well, we're looking at the angle of a circle inscribed on an xy plane. And here we're looking at the arc length of that angle. And the arc length can be denoted by perhaps r, perhaps not. No, arc length is denoted by s, arc length. The r is what we consider the radius of the circle to be, which in this xy plane, we know that the radius, 2 radii, is equal to 1 diameter. The radius is going to be equal to this portion of the x-axis that we're measuring. So we can do that if we have points. Let's say this is x is 1, y is 0. X is 0, y is 0. Well, we can use a distance formula, which in this case it's pretty easy. We know that this is a distance of 1 unit. So it could be inches, centimeters, meters, etc. So to focus back on this, we will just look at S is equal to R times theta. Now this is the important thing here. Theta is the most commonly used, as far as I've seen, measure of an angle. So the angle here, or theta, is equal to the angle that we're examining, which is a 45 positive degree angle. Now, why is this positive? Why aren't we saying, well, if we're going counterclockwise, we're going against the grades of the clock, 12, 1, 2, 3, etc., 6, 9. Why are we measuring it backwards to be positive? This seems counterintuitive into how we represent time, and both of these are circles. Well, that's kind of a funny concept. Time, we tend to think in time of a progression or an advancement of time. So when we're going this way, we tend to think of time as moving forward because that is how we experience time. What? Time? Why are we talking about time? I thought we were talking about radians. Well, if you look, it's all kind of tied into one another. Okay? And so it's important to understand how these concepts are interrelated one with another. So the reason that we're thinking about time is to help understand this is positive, this is negative, but we're dealing with mathematics here, okay? We're not dealing with our conceptions on how we perceive time. So we're going to focus on the mathematics of this. So this is a 45-degree positive angle, and this is the arc length. Now, what does all of this have to do with easily memorizing the arc length, okay, of an angle? Well, this is the chart that we're looking at here that we want to be able to memorize. And so what we want to do is memorize this little looking thing right here. And so we're going to look at the different mathematical, forgive my, wow, this is like, I don't think I could have done that any worse. Well, I probably could have, but it would have been difficult. Let's make it bigger, and maybe bigger is better sometimes. In this case, it certainly seems to be so far. Give me a little more room for a margin of error. Okay. Yeah. It's not beautiful, but it's gonna have to do. Okay. Now there's various relationships here when we look at the ratio of the arc length S over the radius of the circle. And that's kind of what we're doing. Remember with those angles, we had the arc length, the segment, which, by the way, 2 pi radians, well, what is that saying, really? It's saying you've got 2 times the pi, which we know is the infinite irrational number. Excuse me. The infinite irrational number here. And what we're going to consider, if I haven't lost you quite yet, I guarantee you this is worth the wait, because you will actually begin to understand the meaning behind this little graph and the radians here, and what you can actually do with this to get that in-depth understanding. So we have in this case, it's 30 degrees. Okay, pi over 6, pi over 4, pi over 3. Now look at these relationships if you want to memorize this easily. 2 pi, 360 degrees. Okay, what do you think this one is over here? So we've got 30, 45, 60, 90. So we've got our 90-degree angle here. Well, let's just focus on this one first. So what do you think this one would be? If this is going to be 0, and we're moving 30, we got pi over 6, pi over 4, pi over 3. You wouldn't be able to guess it just based on this information. It would be difficult to guess it at the very least. But if we go back to this, so we've got 2 pi radians is 360 degrees. Well, we can probably pretty easily guess what 180 degrees is, right? Because that's just going to be half of 360. So what do you think this is over here? That's right. It's going to be pi. Okay? And then what's this over here then? Well, pi, 0, pi. Looks like we're kind of in the middle. That's right, it's pi over 2. So what does this have to do with easily memorizing this? Well, look, there's a pattern here. 6, 4, 3, 2. These are the only bottom numbers, 3, 4, 6, that we're dealing with. And then we just have pi. And then what do you think this is? Guess what? 6, 4, 3, 2, 3, 4, 6. It's just that easy. So if we understand the interrelationship of these different things, it becomes a much easier to memorize all of these different numbers and interrelated things here, because they are all interrelated, and that is mathematics, is the pattern of relationships. Now, we've got pi over 2, so what do we think this one is? What do we think this one is? Well, I know this one's 5. And part of this does come down to just memorization, but it's helpful to know what we're actually memorizing so that it doesn't just seem like we're memorizing numbers for their own sake, because we're looking at the relationship of the arc length to the radius, and understanding all of this will help us to derive certain conclusions on calculating the arc length of various different angles and various different properties. This is kind of like a base fundamental of knowledge. So if I can stop procrastinating, okay, I believe 5, 7, 11, I want to say 2, 2, 3, 5. Don't quote me on that. Let me look at my cheat sheet. Where's my cheat sheet? Yes, I did that right. Okay, good. 2, 3, 5. Then down here, I think we go backwards. I'm lost on this corner. Okay, no, this one's tricky. 7, 5, 4. So that is one quadrant that I am a little fuzzy on. Again, when I say quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that is our little radian circle here. So the way to easily memorize this, 6, 4, 3, 2, 3, 4, 6. Then again, we know this one's just pi. So pi over 6, pi over 4. So 7. So 6, 4, 3, 2, 3, 4, 6. Bop. 6, 4, 3, 2, 3, 4, 6. And then we've got our full revolution here. One more important point to illustrate, I think, and why radians are interesting. Interesting? Question mark? What is possibly interesting about a radian? The radian it's a ratio, right? It's a ratio of 2 units, which means that the units cancel out, which means we don't really write the units of the radian in terms of like inches squared or inches because they cancel out. One other interesting fact about radians is that it is like taking the radius of the circle and inscribing that on the arc length. So you have, so then what does that mean? Well, it means we have one radius. Where is the radius? So 1 radians, I have that written down. Give me a second to find it. Okay, it's like right around pi over, I think the first radian is right around here, actually. 1 radian. Don't quote me on that. 2 radians is right around here. Okay, the 3rd radian is around over here. You're like, wait, you're confusing me. Okay, we're not looking at 3 pi radians. We're not looking at 3 pi over 2 radians, right? Because that's what all these are. We've got pi over 2 radians, pi radians. Because again, what is pi? Pi, 3.14159. What is pi? What is pi? I'm so lost right now. Honestly, I'm lost too. I'm thinking about pi. I guess we'll make that another video. I'll have to research it and figure it out. I don't even know what pi is. All I know is the number 3.14159, something, something, something else. It goes on forever. Good thing I'm not listing out every digit that exists. We'll leave that to the computers. But as of right now, we'll just focus on the fact that 3 pi over 2 is not what we're talking about. We're talking about a whole number of radians. So 3 radians is right about there. You'll understand what this means in just a second. 4 radians, I don't know, I want to say it's like right here, over here or something. And then 5 radians. Where is that? If I had to guess, I actually don't see it written down, but if I had to guess, I guess it's like around here somewhere. 5 radians. 6, I'd want to say is like right here. And then we've got a little bit left, right? Because what is 2 pi radians? Well, we know pi as a number is 3.14159. Conceptually, still not sure I know what pi is conceptually, which is a little disappointing, considering I've been using pi for like, I don't know how many years. So we take 2 times 3.14159, which is, guess is approximately 6.28, blah, blah, blah. So this is the leftover little portion. So this right here is 2.8. So what does this mean? Well, it means that the radius of the circle is being fit across the circumference of a circle around 2 pi times, or around 6.28 blah, blah, blah times. So why in the living glogly gloggle are we like doing all this? I don't know. But hey, we'll figure it out eventually, right? Because it's important to understand what angles are and the relationships that angles have to these various geometric shapes. Because we can look at the radians of a triangle, trigonometry. What is that, like the study of triangles? Gee, golly, we're studying triangles. Oh. Okay, well, I can accept that. I can accept the fact that I'm studying triangles, because guess what? Pyramids are pretty cool, right? Pyramids are cool. And you know what else are cool? Honeycombs. Honeycombs are pretty cool. And if we could understand the radian angle of a honeycomb, maybe we could figure out how to build little hexagons in hexagons or like triangles within hexagons and then other little shapes that fit in or something like that. I mean, look, I could do anything within this hexagon. I can make like little circles in here. You know what I mean? But then guess what? You've got another hexagon right here as an outer shape. But then as an inner shape, I can just put in another circle. And then I can maybe like calculate the angle of that to make this little shape right here and make all of this just like perfect. You know what I'm saying? What? All right, that's enough. This has been fun. I've definitely. Let's see if I can get the second quadrant down again. 1, 2, 3. Is it 7, 5, 4? Yes. Good. Okay. 7, 5, 4. Okay. Have a great day.